Ever heard of, like, sound laser?
Sound laser.
Yeah, like lasers, but with sound waves instead of light. Crazy, right?
That does sound pretty wild.
Right. It's like something straight out of Star Wars or something.
Yeah, like those sonic weapons you see in movies.
Exactly. Except this is real deal science, and it's got way more potential for good than blowing stuff up.
I'm all ears. Tell me more.
So, today we're diving deep into the world of sound lasers, how they work, why they're such a big deal, and what they could mean for, well, pretty much everything.
Sounds like a fascinating deep dive.
It really is. And to help us unpack all of it, we've got a real expert in the house.
Happy to be here.
Thanks for joining us. Okay, so before we blow anyone's mind with the specifics, anyone listening might already know this, but just to level set, lasers are all about light, right?
Exactly. Regular lasers use light waves.
And those light waves are super organized, right? Like marching in perfect formation.
Yeah, you got it. That's what makes lasers so powerful. They're what we call coherent. All the light waves are vibrating together in sync.
And that's what lets them focus so tightly, right? Like that's how you get that super precise beam.
You got it. It's that coherence that lets us do all sorts of amazing things with lasers, from cutting steel to performing surgery.
But sound waves are way more unruly. It's like trying to herd cats to get those to behave right.
Huh. That's a good way to put it. Sound waves are way more chaotic than light waves.
Way more. They're jumbled up with all these different frequencies going every which way. So how in the world do you even begin to wrangle them into a laser-like beam? That's where things get really mind-bending, right?
It is. And that's what makes sound lasers so incredible. It took a lot of ingenuity to figure out how to do it. It boils down to this idea of controlling those frequencies. With light, all the waves are pretty much the same, but sound is messy. Different frequencies, different wavelengths, it's all over the place.
Right. It's like a whole orchestra playing at once instead of just one clean note.
Exactly. And that's why it was so hard to make a sound laser. How do you get all those different sound waves to line up and act like a single focused beam?
Right. It seems impossible.
It almost was. But scientists found a way. And to explain it, we need to talk about a really, really small object.
Smaller than a bread box.
Way smaller. We're talking about a tiny sphere of silicon oxide. Picture something like a millionth of a meter across.
Wow, that's tiny. What could they even do with something that small?
This is where it gets really cool. They suspended this tiny sphere in midair using lasers.
Wait, so they're using lasers to trap sound. That's already bending my brain a little.
That's just the beginning. So they've got this tiny sphere just floating there, held by light. And then they made it vibrate.
Vibrate, like a bell.
Kind of. But instead of hitting it, they used an electrical field to make it oscillate at very specific frequencies.
Hold on, I need to picture this. So they're using lasers to hold this tiny ball and electricity to make it vibrate. Science is so cool.
I know, right? But here's the real kicker. By carefully tuning that electrical field, they could amplify specific sound waves coming from the sphere up to 1,000 times louder.
1,000 times. So it's like taking a whisper and turning it into a rock concert just with this tiny vibrating ball.
You got it. And that massive amplification is key because it creates a much more focused beam of sound, kind of like a regular laser with light.
Okay, so now my mind is officially blown. They figured out how to focus sound like a laser, and they do it with a tiny ball and some seriously precise lasers and electrical fields.
They're pretty impressive, huh?
It really is. But let's talk about what we can actually do with a sound laser. This can't just be about making tiny objects sing opera, right?
No way. The potential applications are huge. This technology could revolutionize everything from medical imaging to how we communicate.
Give me an example. What's the coolest thing this tech could do?
Well, for starters, imagine being able to see inside anything with incredible detail, and I'm talking about seeing things at the subatomic level. That's the kind of resolution that sound lasers could offer, which would be huge for fields like material science.
Wait, so, like, instead of just looking at a cell under a microscope, we could look at the individual atoms that make it up.
Exactly. We could see how materials are structured at the most fundamental level. That kind of detail could lead to breakthroughs in developing new materials that are stronger, lighter, more durable.
And all because we can now see them better with these sound lasers.
Precisely. We're talking about the potential for lighter, stronger building materials, more efficient solar cells, even advances in nanotechnology that we can barely imagine yet.
Okay, that's amazing. But what about those communication applications you mentioned? How would sound lasers change things there?
Think about it. Sound waves can travel through things that light can't. So imagine being able to send highly secure data through walls, underwater, even deep underground,
So instead of using radio waves for sonar, we could use sound lasers to communicate with submarines or underwater research stations, even in the deepest parts of the ocean.
Exactly. Or think about disaster relief efforts. After an earthquake, communication lines are often down. But sound lasers could be used to send signals through rubble and debris,
Wow.
potentially locating survivors and coordinating rescue efforts more effectively.
It's like something out of a movie, but it's real. That's incredible.
And that's not all. This technology could revolutionize fields like medical imaging, allowing doctors to see inside the human body with unprecedented clarity and diagnose diseases at earlier stages.
So basically, this one discovery, this ability to focus sound like light, it has the potential to touch every aspect of our lives.
It really does. It's a fundamental breakthrough that could lead to innovations we haven't even dreamed of yet. Who knows what the future holds for sound lasers?
That's the craziest part. We're just scratching the surface of what's possible. Well, on that note, any final thoughts for our listeners?
Just this. If we can manipulate sound like light, what does that mean for controlling other types of waves? Could we one day laser things we haven't even imagined yet? That's something to think about.
That is something to think about. A world where we can manipulate not just sound and light, but any type of wave we can dream up.
The possibilities are endless.
Truly mind-blowing. Well, that's all the time we have for today's deep dive. Thanks for joining us, and a huge thank you to our expert for shedding light on the fascinating world of sound lasers. Until next time, keep exploring the edges of science and technology. You never know what incredible discoveries await.